Please welcome to the stage Acting Administrator of the Exploration Systems Development Mission Directorate, Dr. Lori Glaze.
Good morning. It is so wonderful to see so many of our industry and international partners here today. It is my absolute pleasure and honor to talk to you this morning about the very first, most critical step in that vision that Jared just spoke about, the return to the moon. If I could have the next slide, please. On February 27th, just a couple of weeks ago, the administrator announced his bold plan to increase the cadence of missions under the Artemis program to achieve the national objective of returning to the moon, of returning our American astronauts to the moon and establishing an enduring presence. This includes standardizing our vehicle configuration, adding an additional mission in 2027, as Jared just alluded to, and undertaking at least one crewed surface landing every year thereafter. The revised sequence enables a more rapid cadence to retain our muscle memory. We've talked about our muscle memory that's been developed during launch and flight operations, and ensures that the critical landing systems are tested with crew before attempting operations on the lunar surface, dramatically reducing our mission risk. To enable these changes, as Jared just spoke to, NASA will engage in a concerted hardware, software, and analysis acceleration effort. The effort will redeploy the workforce to engage more directly with our providers, to provide relief if needed, and bring some of the manufacturing in-house if necessary. Looking beyond Artemis 5, NASA plans to work with at least 2 launch providers, initially targeting landings every 6 months, with the potential to increase the cadence as the capabilities mature. An RFI has just been released at the beginning of this presentation, or should have been at the beginning of this presentation, to solicit information from our established commercial providers and new industry entrants to help shape NASA's long-term strategy to transition from government-driven missions to the commercially sustained lunar transportation ecosystem for Artemis 6 and beyond. If I could have the next slide, please. We're following the proven stepwise approach that was demonstrated by the Apollo missions to methodically reduce risk incrementally and increase the likelihood of mission success. If I could have the next slide. With Artemis, we're applying the same stepwise approach. Each step needs to be big enough to make progress, but not so big that we take unnecessary risks given and based on our previous learnings. In this model, Artemis 2, as we all are aware, will demonstrate Orion crewed operations, including critical tests of environmental control and life support systems, and manual spacecraft maneuvering as part of a proximity operations demonstration prior to the translunar injection. Artemis 3 is now being replanned as an Earth orbit test flight, demonstrating integrated launches with rendezvous and docking demonstrations with one or both of the lander providers. Artemis 4 will perform the first crewed landing in early 2028, and Artemis 5 is targeted later in 2028 to further accelerate towards establishing the lunar base. If I could have the next slide. I'm going to take a couple of moments to talk about Artemis 2. Near and dear, this is the very first critical step in the success of this plan. We've got to successfully complete Artemis 2. And I got a lot of great things to tell you about it. Next slide. Came to my realization over the last couple of days. I've been talking about launching on April 1st for a few weeks now. And then the last couple of days, I just kind of came to my mind, that's 1 week from tomorrow. 1 week. Yes. I can tell you, I was just out at the pad last Friday as we rolled the spacecraft back out to the pad. We've been tracking it day by day in the preparations leading up to launch. And I can tell you that as of this moment right now, there are no major issues that we're working. We are doing everything according to plan. We're following the plan. We'll be watching the weather very closely over the next week. We'll also be staying alert for anything that may go a little astray. We want to assure that our astronauts, our 3 American and Canadian crew, are all safe for this mission. We've already passed our final big review, the flight readiness review, on March 11th and 12th, so that milestone is behind us. And we are now, as I said, aiming for April 1st. The launch window extends from the 1st through the 6th, and there should be about 4 attempts possible within that 6-day period. If we can go to the next slide, thank you. So I'll give you just a little bit about the mission plan for Artemis II. I like to basically break it up into about 4 phases. I'm not going to speak to everything on this slide, but we can think of it in 4 different parts. The first part of the mission is the launch, and then we go into this 24-hour high Earth orbit. While we're in that high Earth orbit, we are going to check out the environmental control and life support systems. This is the newest piece for Artemis II and the critical piece for supporting our crew and keeping them safe and healthy throughout the mission. While we're in that 24-hour orbit, we will also conduct the proximity operations demonstration. Once we have separated from the ICPS, the interim cryogenic propulsion stage, our upper stage, we will use the manual controls in Orion to approach and then regress and then approach the ICPS to see and get better feel for how those controls respond to the crew's direction. Once we're confident that all of the systems are operating within the Orion spacecraft at the completion of that 24-hour orbit, we will perform the translunar injection, which sets us on the path to the moon, around, and back, where we'll use the moon's gravity to bring us back. It's a free return trajectory. So that second phase is about 4 days out to the moon. And then we have the third phase, which is the lunar flyby, where we'll get to observe the far side of the moon and hopefully break the record, the Apollo record, for the farthest any human has ever flown from Earth. And then we begin the cruise back, about another 4 days back to Earth. The final part of the mission is the re-entry to Earth's atmosphere and splashdown off the coast of San Diego in the Pacific Ocean. We'll work closely with our partners at the Department of War to recover the crew, bring them safely to shore, and return them to Johnson Space Center. So I hope you all have as much excitement as I do. I'm starting to get goosebumps. Please stay tuned and watch along with us over the coming week. And I hope to see many of you at the launch next week. If I could have the next slide. Oh, it's up already. Artemis III, as we mentioned, is now a new Earth orbit docking demonstration in 2027. And we're really excited about this mission. And I want to talk about all the preparations we've already made and how ready we are to execute on this mission in 2027. The hardware for Artemis III is very mature, and we're working to meet the 2027 launch readiness. As soon as we complete the launch of Artemis II, we will assess the condition of the mobile launch pad. We made significant changes to ruggedize the mobile launcher following Artemis I, and so we anticipate the ability to turn the pad around very quickly and begin preparations for stacking of the Artemis III rocket. The Space Launch System hardware, the rocket hardware, most of it, a lot of it's already at Kennedy Space Center. We'll have a lot more of it there very, very soon. The interim cryogenic propulsion stage, the ICPS, is ready. We may need it for Artemis III, we may save it for Artemis IV, but it is ready. The boosters, the solid rocket boosters, have been ready for a while. They were just waiting for space in the vehicle assembly building. We anticipate shipping those and receiving them at KSC in April, later in April. The engine section for the core stage for Artemis III is already in the vehicle assembly building undergoing integration work. The RS-25 engines are ready and they're shipping in April. The top 4/5 of the core stage should be shipping from the Michoud Assembly Facility in April, actually a week or two after the Artemis II mission completes. We expect to receive those down at Kennedy Space Center, the core stage. And the launch vehicle stage adapter is also ready in storage at Marshall Space Flight Center, and we anticipate that shipping to KSC as well. Next slide. Our Orion team is also working hard to meet the challenge of a 2027 launch. All elements are already at the Neil Armstrong Operations and Checkout Building at Kennedy Space Center, and significant progress is already underway. The Orion service module is in testing and checkout, making great progress. The heat shield that you see in the middle here has completed its fabrication and assembly, and it's in its final preparations to be ready to be integrated into the Orion crew module. The service module is also being integrated and tested. So we've got the service module, the crew module, we've got all the piece parts. We are in that integration stage. The next slide, please. Of course, in order to perform this important docking demonstration, we are going to partner closely with both of our human landing system providers. The goal for this mission is for Orion to dock with one or both of those landers, and both of the HLS providers already have been given a task. They were given that task immediately following Jared's announcement to assess the options for this new Artemis 3 mission profile. In preparations, we're watching closely the development of both lander systems. The Starship flight test number 12, we anticipate happening in April, hopefully, no earlier than, but hopefully in April, will be the first flight of their version 3, which is a major step towards a lunar landing capability. The Blue Origin, Mark 1, which is their predecessor to the Mark 2 human lander. They've invested a great deal in the Mark 1 lander and anticipate launching that within a few months. Very excited. It's going to be flying one of Nikki's CLIPS payloads. And we'll be watching. There's a lot of commonalities with the systems needed for the human lander that will buy down risk with this Mark 1 mission. Back in the fall of 2025, NASA already began working with both of the providers to accelerate the human landing to 2028. Those accelerated landers are what we will be using for the Artemis 3 rendezvous and docking demonstration to buy down the risks. I have the next slide, please. So as soon as the administrator made his announcement, we began actively assessing the specifics of the mission profile and the objectives that can be addressed in this mission. The new mission will endeavor to include a rendezvous and docking with one or both commercial landers, as I said, from SpaceX and Blue Origin. It will include in-space tests of the docked vehicles, an integrated checkout of life support, the docked vehicles, the communications, and the propulsion systems. We also really hope to be able to include the new extravehicular activity suits in the landers to help reduce future risks on their development. NASA will further define this test flight after we complete the detailed reviews that we are conducting right now actively between NASA and our industry partners. And the agency will, of course, share the specifics, the specific objectives for the updated Artemis 3 mission in the very, very near future. The primary objectives that we're considering as part of this mission profile include things like demonstrating the multi-launch campaign coordination. This is not simple. We need to have multiple rockets launching in a coordinated fashion such that we can all meet up together in space at the same time and place. Of course, the Orion rendezvous and proximity operations with the landers in orbit is one of the primary objectives. We want to work through crewed docking operations. We would really like to test those surface suits if possible. We'll be testing the critical lander systems and lander vehicle performance while in Earth orbit. And we'll be looking at performance of the new Orion permeable heat shield. We have the new, more permeable heat shield we'll be flying on Orion for Artemis 3. And while the Earth orbit won't put quite the demands on it that we would have returning from the moon, we will gather important data on the performance of that heat shield. We'll also get practice in increasing the mission cadence with a prompt turnaround of the pad and the ground systems, really pressing that system to do a quick turnaround. And we've talked a lot about the muscle memory, and with this mission we'll really demonstrate our ability to support the increasing mission cadence. With Artemis 4 in early 2028, NASA has undertaken an effort to work with both of the HLS providers to request and assess their proposals to accelerate the lander development. Jared referred to that earlier. This includes modifications to our requirements and then also to the surface things that we want them to do on the surface and how we want them to work with us. We've got requirements to the hardware, the mission definitions, capabilities that enable us to move faster. We're really focusing on how can we move faster. The intent with this change, with trying to pull these forward and working with both providers, is to fly with whichever provider is ready first for 2027. We've already made significant progress on the government side of the hardware that's required for Artemis 4, both on the SLS and the Orion. The solid rocket booster segments are complete. The aft skirts for the boosters are in their final production. The core stage engine section for Artemis 4 is actually already at Kennedy Space Center. The RS-25 engines are in storage. The top 4/5 of the core stage are in their manufacturing at Michoud Assembly Facility. And the Orion Crew Module is also in its final assembly at ONC at Kennedy Space Center. And the Orion Service Module that's provided by our European partners is also well into its integration in Germany. We had the, Artemis 4 is here at KSC. Sorry, getting lost in my track here. We've got a lot of stuff here. Artemis 4 is here at Kennedy Space Center, which is already getting integrated. As I mentioned, we only have one more ICPS. We're in the process of determining whether it would be used for Artemis 3 or 4. But as part of the plan to standardize production of the transportation system, the exploration upper stage that was previously planned for Artemis 4 has been replaced with the Centaur 5, which is a proven capability as part of the ULA Vulcan launch system. Right now, all of our programs are actively engaged in understanding what modifications will be needed to be implemented in order to transition from ICPS to the Centaur 5 upper stage. The new generation suits are being developed by Axiom to support NASA's lunar surface extravehicular activities. This is a significant effort and critical to our ability to execute the first landed mission. NASA is accelerating this effort, and we're providing direct support at Axiom facilities and suppliers to increase the collaboration and accelerate hardware production. The Axiom suits are being planned for checkout, as I said, hopefully on Artemis 3, or possibly additionally on the ISS. The suits for the mission for Artemis 4 will be delivered to the human landing system for integration. Again, both of our providers for Artemis 4 are working on simplifying their profiles to accelerate the initial landings and those surface capabilities. The primary goal of this mission for Artemis 4 is to execute the first crewed landing since 1972. While in orbit around the moon, the two crew will have two crew transfer from Orion to the commercial lander, and then which will safely transport those two crew to the surface of the moon, and then ultimately bring them back to rendezvous with Orion in lunar orbit. While they're on the moon, the two crew will demonstrate surface operations, including deployment of science instruments and conducting an integrated surface science campaign. Both of the providers are required to complete a successful uncrewed landing prior to carrying any of our crew. We've been looking and talking with both of the providers. SpaceX has been considering alternatives of their current Starship design, of the HLS Starship design, while implementing a more streamlined approach to try and speed things up and pull things forward. The Blue Origin approach implements existing capabilities that they have today as a stepping stone toward their eventual full capacity architecture. We've asked both teams for feedback. How can we help simplify these missions, and how can we speed up the landing? And the overarching themes that we've heard from both SpaceX and Blue Origin were, first off, can we please avoid the near rectilinear halo orbit? Can we please avoid NRHO to help reduce the HLS workload, what's required of that system, and also improve lunar surface mission planning flexibility? We've also heard that simplifying the mission requirements for this initial mission while maintaining their long-term capability is also a strong desire. We want to simplify, but we also want to make sure we're building towards the future. So it's important to assure that whatever architecture we're using for Artemis 4 feeds forward to what's going to be needed in the future. In response to the feedback that we've received from SpaceX and Blue Origin, we are indicating, and we have indicated to both of them, that we are open to other non-NRHO lunar orbits. Some of these orbits could reduce our crew risk with abort opportunities that are available in hours versus up to a week if we were in NRHO parking orbit. It also opens up flexibility in surface mission planning, allowing us perhaps access to different sites on the surface or flexibility in the timing of when we land. The intent of offering alternate orbits is to balance the Orion and lander performance by parking closer to the moon and being able to have that more frequent or easier access. We're also looking at the surface requirements, trying to make them simple and sustainable. We're looking at more flexible surface planning that supports simplified interfaces, leading to accelerated development. We are, of course, also looking for maintaining that long-term capability. So the simplification of the requirements allows us to focus on achieving the near-term goals while also preserving the long-term goals through evolution of the lander capabilities to support our exploration goals. Looking forward in working with the providers and with our teams within NASA, we're very focused on looking at the cross-program and mission planning. There are critical Orion interfaces, and those interface definitions need to be updated. They require being updated to trying to understand what it means in these new parking orbits that are closer to the moon and different mission profiles. So we're in the process of assessing that all right now. Moving on to Artemis 5, which would be the second landed mission in late 2028, as we begin our preparations for a lunar base. There is significant hardware, again, already in development for Artemis 5. Orion Crew Module, European Service Module, this one is in Germany still, but we expect it to be delivered next fall. They're on an excellent yearly cadence of providing those service modules. We've got engines in production, boosters in productions, and the core stage already also in manufacturing. So I'd like to wrap up here. I just want to hope to close with the impression that you'll take away that we are enthusiastic and excited to execute on these accelerated timelines. The new Artemis 3 mission standardizes the architecture and will reduce risks ahead of the first lunar landing. We have the hardware, we have the skills, we have the capabilities to accelerate, and we know this administration is committed to removing any of the obstacles that are slowing us down. We're also prepared to advocate for increased supply chain criticality, and we're poised to deploy the NASA workforce to build components ourselves if necessary. We're already embedding NASA personnel at key contractors and suppliers as active, not passive, participants in the supply chain to assure that the key components that we need are not keeping us from landing on the moon first. Internally, we're in the process of building new analysis tools that provide us insight and real-time resolution of challenges across the entire Artemis enterprise. And to assure that we're all moving and working toward the common goal, the administrator has invited the company leaders from each of our prime industry partners to brief him within the next few weeks on the actions they're taking to meet the accelerated schedule. As I noted at the beginning, we're signaling demand and dropping an RFI for 2 pathways for crewed missions to the moon beyond Artemis 5. The first step in this journey begins with the Artemis 2 launch on April 1st, when Reed, Victor, Christina, Jeremy embark on their historic journey around the moon. I hope you'll be watching. I hope you'll be watching very closely, hopefully from the Cape, as we lay the foundation for Artemis 3, 4, 5, and beyond. And as Administrator Isaacman has said repeatedly, we may not have captured full global attention yet, but I'm absolutely certain that as we embark on Artemis 2, 3, 4, and 5 in the coming years, we will captivate the world. We're honored to have you working alongside us to further world-changing science and discovery. Thank you.